All right, I need your attention. Get out your notes, please. Without your notes, please. And label your notes. This is going to be section 4.2, trigonometric. Trigonometric functions.
Say that again. No. Trigonometric.
Trigonometric functions.
That's too much.
And I just want to refresh your memory, and some of you already mentioned this to me just a moment ago, that actually Marcus said the sine is always the y value, and the cosine was the x value. And you guys need to know that very, very well. X is the cosine, y is the sine. Are you with me here?
Yes.
Ooh.
Sure. No.
When you are, and we talked about this, I don't know, last week sometime or a couple weeks ago, when we looked at the unit circle, we said, for example, that if you are talking about a 30-degree angle, in other words, a 30-degree arc, remember how it created this right triangle? Had a right angle right there in the corner. And this point right here on the circle has an x value and a y value. So from the center of the circle, which is actually the point 0, 0, the origin, this point up here on the unit circle is to the right x units, and it is up y units. Do you remember talking about that?
Yes.
We also called this the 1 unit circle, and we called it the 1 unit circle because the radius of the circle is 1. Are you with me here?
I'm aware.
So then we went back to SOHCAHTOA, and we said that the cosine of 30 degrees, in this case 30 degrees, was the adjacent side, which is x, divided by 1. Would you agree?
Yes.
We said it was the cosine of theta was x divided by 1. So in this case, you just had to know the x value, you divided it by 1. We went through, we calculated that the x value here was the same thing as taking the cosine of 30 and multiplying it by 1, which I believe got us, what's the cosine of 30 degrees? You guys look at the table that you just filled out. Isn't it the square root of 3 over 2?
Yeah.
All right, and then to find the sine of 30 degrees, we had to take opposite, which in this case was the y value divided by the hypotenuse, which is 1. So the sine of 30 degrees is y divided by 1. Are you still with me?
Good.
You guys, what is x divided by 1?
X.
It is x. So in other words, that's why the cosine value is always just the x value. What is y divided by 1? It is y. So the sine of whatever angle you're talking about is always just the y value. Yes?
So say you had like a 4.5 unit circle, and
Yep.
you did the same thing. Would it just be like the square root of 3 over 2 times 4.5?
Yes, it would.
Oh.
Yep. Yes, it would. All right. Now, let's go off of what you just said. Let's change this up a little bit, and let's not call it specifically the cosine of 30. Let's call it the cosine of theta. The cosine of theta. In other words, this is not 30 degrees. We're going to call 30 degrees. We're just going to call it theta instead. Theta just meaning, you guys, like x. It's just x. We're calling it theta because we're talking about angles. The cosine of theta is equal to the adjacent side, which is x, divided by, in this case we said it was divided by 1, because 1 is the radius. Well, let's say it's not 1. As Marcus just said, what if the radius was 4.5?
Hello.
I don't know.
Okay, I have to admit, I'm getting a little irritated because it seems like you guys are more focused on whatever's going on over there than what you're supposed to be learning right now, okay? Thanksgiving break is over. I need you back. Okay? Whatever's going on, put the phone away or whatever. Okay,
I
thank
didn't
you.
know it was gonna go off. I didn't
All right.
make
The cosine of theta is equal to adjacent divided by hypotenuse. In this case, the hypotenuse is 1. Well, what if it wasn't 1? What if it was something else? What is this of the circle, you guys? What is this 1?
that is radius.
It is the radius. So really all we did was to find the cosine, we took x divided by the radius. Are you with me? So cosine is actually the same thing as taking the x value divided by the radius. What if it is the sine of theta? Well, the sine of theta is opposite, which is y, divided by the hypotenuse, which in this circle right here is 1, but let's say the radius is not 1. Let's just say it is something else. So in other words, to find the sine value, you always take the y value divided by what? What's the radius? What are we going to call the radius? Let's just call it r. Yeah. So r could be anything, whatever the radius is. But now what we're going to do is take this a step further. We, up until now, have really only talked about sine and cosine. What I need to start talking about now is the tangent. So what does tangent mean? When you think of SOHCAHTOA, what does tangent mean? Yes.
Isn't that the opposite over the adjacent?
Yes. Tangent means opposite divided by adjacent. So let's go back to this circle. If this is theta, right here in the center, I know you can't even read that it says theta, that is theta. Tangent means opposite divided by adjacent. What is opposite of theta?
Y
It is y.
over X.
What is adjacent?
X.
It is x. So in other words, the tangent of theta is equal to y divided by x. You guys, what is y?
Y, put it up, is half.
We do not. Kind of.
0.5. You want the
What is
numerical
y?
value of y?
Nope. Y is the same thing as the sine of, here we're talking about 30 degrees, but it doesn't have to be 30 degrees, it can be anything.
Theta.
So y is the same thing as the sine. And then x is the same thing as cosine. So when we say that tangent is the y value divided by the x value, it is important for you to know that y divided by x really just means, y again is sine, it's taking the sine of theta and dividing it by the cosine of theta. That's something that you need to commit to memory. Tangent means sine divided by cosine. Sine of theta divided by the cosine of theta. So, let's say that we are at a point on the unit circle. I'm going to draw myself a new circle. Let's say that we right now are at, let's go to pi over 4. Pi over 4. I believe the coordinates here are the square root of 2 over 2, comma, the square root of 2 over 2. Are you with me?
Yes.
Okay. What is this value right here? What is the very first value in this coordinate pair? What is that called? It's the cosine. Yeah, this is the cosine of pi over 4. What is this one? It is the sine. So to calculate the tangent at pi over 4, you need to take the, what did we just say the tangent was? It is what divided by what?
Sine.
It is the sine divided by the cosine. So what is the sine at pi over 4?
It's gonna equal 1.
It is the square root of 2 over 2 divided by the cosine value, which is square root of 2 over 2. You guys, what is the square root of 2 over 2 divided by the square root of 2 over 2?
1.
Is 1. So the tangent of pi over 4 is actually 1. Does that make sense?
Yeah.
It is amazing,
So that's the
isn't it?
radius.
What'd you say?
So like 1 would be like the radius. Oh.
That just means that in this triangle, technically you are over 1 unit, and you are up 1 unit also. Because this
Yeah, the radius is whatever.
okay. Let's do pi over 3. Pi over 3. Okay, now if my memory serves me correctly, pi over 3 really means 1/2 comma the square root of 3 over 2. Am I right, you guys? Uh-oh, I didn't mean to do that. Am I right? 1/2 comma the square root of 3 over 2?
Yes.
All right, so let's calculate the tangent of pi over 3. Well, tangent means sine divided by cosine, correct? What is the sine value at pi over 3?
The square root of 3 over 2.
Okay, are you guys okay with that? Because I'm not getting a lot of responses from people.
Yeah.
The sine is the second number, the y value, the square root of 3 over 2, divided by the cosine value, which is 1/2. So the tangent of pi over 3 is the square root of 3 over 2 divided by 1/2. That's awful. But I want you guys to recognize something. When you are doing a problem like this, you're taking a fraction divided by a fraction. When you divide by a fraction, that is the same thing as multiplying by the reciprocal. So really what you're doing is you're getting rid of the 1/2 on the bottom by multiplying by 2 over 1. The 2 over 1 and the 1/2 cancel each other out, but then you have to multiply the numerator by the same thing too. So you're actually multiplying by 2 over 1 on the top. So this 2 on the top and the 2 on the bottom, they cancel out, and it leaves you with what? Square root of 3. So this is what I want you guys to recognize. This is what we started with. We started with the square root of 3 over 2, and we have to divide that by 1/2. So we have a fraction on the top divided by a fraction on the bottom. Look at these fractions. The fractions have the same what?
Denominator.
They have the same denominator, and if that's the case, they cancel each other right out. All you're left with is the numerator of the numerator divided by the numerator of the denominator, if that makes sense.
I feel like this
So it's always the square root of 3 divided by the other numerator, which is 1. So just keep that in mind. A little shortcut you guys can use, because you're going to be doing a lot of this kind of stuff. So the tangent of pi over 3 is the same thing as the square root of 3. You okay with that?
I feel like these numbers are going to show up a lot.
They
both
are.
Positive and negative.
They will be your best friend.
Just about everywhere, right?
Okay, maybe not.
Really.
Okay, what I would like you guys to do now is look at your unit circles or at the tables that you just filled out. What I want you to do now is the tangent. I'm gonna go backwards a little bit. Let's do the tangent of pi over 6. The tangent of pi over 6. Well, you guys, again, tangent always means the sine divided by the cosine. Sine divided by cosine. So the tangent of pi over 6 is the sine, which I believe is 1/2. Am I right?
Yeah.
The sine of pi over 6 is 1/2.
Where's pi over 6?
Okay, I need more confirmation than that.
Yes,
Yeah.
it is
Thank
Miss
you.
Corrigan.
The sine of pi over 6 is 1/2 divided by the cosine of pi over 6. What is the cosine of pi over 6? Square root of 3 over 2. All right, so you guys, that little trick I just showed you,
Does that work here?
does it work here? Are the denominators the
Yes.
same in each fraction? Yes.
Yes.
So cancel them right out. What are you left with?
1 over the square root of
1 over the square root of 3. Okay, now this is the problem. Everyone listen to me, listen to me. Do not assume you know what's going on right now. In the bottom of this fraction, we have a square root.
Yes.
And that is not proper in mathematics to leave a square root on the bottom. So we need to get rid of it. And I'm thinking maybe we did some some variation of this at some point this year.
No.
But if you have a square root on the bottom, you need to get rid of it. So we need to do this thing called rationalizing the denominator. The square root of 3 is an irrational number.
Yes.
We have to get rid of that. So to get rid of it, this is what we're going to do. And follow these steps. It's not hard, but you maybe new information to you. What you need to do is multiply the denominator by the square root of 3. But the problem is if you only multiply the denominator by the square root of 3, you have changed the value of the fraction. So if you multiply the denominator by the square root of 3, what must you do to the numerator? Multiply by the square root of 3. So really what I am doing, you guys, what is this? What is the square root of 3 over the square root of 3? It is 1. You have just multiplied that fraction by 1. Multiplying something by 1 doesn't change the value. Does that make sense? If you multiply by 1, you are not you're not changing the value of the original expression. All right, let's clean this up. What is 1 times the square root of 3? It is the square, it is the square root of 3. What is the square root of 3 times the square root of 3? Square root of 9. What is the square root of 9?
3.
It is 3.
So
you have 3, the square root of 3 over 3. So I'm going to show you the math here. The square root of 3 times the square root of 3, that is the same thing as the square root of 9. What is the square root of 9? Square root of 9 is 3. That's where that came from. That's where this 3 right here came from. All right, let's do another one. What I want you to do now is do the tangent of 0. 0 pi. What does the sine, or excuse me, what does the tangent mean again?
That's a cosine. Oh, no, it's a sine.
Sine divided by the cosine. What is the sine of 0? 0. What is the cosine of 0?
1.
It is 1. What is 0 divided by 1?
0.
It is 0. All right, so the tangent of 0, which is, by the way, is the same thing as the tangent of 2 pi, it is 0. Let's do another one. What about the tangent of pi over 2? Go to pi over 2 on your circle. That's 90 degrees. Tangent means sine divided by cosine. What is the sine of 90 degrees, or pi over 2? It is 1. What is the cosine of pi over 2?
0.
0. There's a problem here. What is 1 divided by 0? It is undefined. So my point is this. The tangent does not exist at pi over 2. And it just so happens that pi over 2 in this function is called an asymptote. But we're not going to get into it. We are not going to get into that. If you were to graph this, there would be an asymptote at pi over 2. So, but all I am concerned about at this point is that you guys know that the tangent of pi over 2 is undefined. Yes?
Is it the same thing with pi?
270 degrees, it will be undefined, yep. What about pi? Go to pi.
It would be 0.
Pi, yep, it would be 0 divided by negative 1. 0 divided by negative 1 would be 0. Alright, so this is what's happening now. You guys at this point should be able to fill out the entire tangent row of your table. And most of you, or some of you, it looks like you've already done that. So you're going to need, that's going to be something you're going to need to do tonight, is to go through and fill out the tangent row. But I want to take this one step further because we have just a few minutes here. Yes?
So what you're trying to tell me is the sine is the y value, and the cosine is the x value, and the tangent is the slope.
The tangent is the slope. Sure. Yeah.
Okay.
Yes.
That's what this is figuring out.
Well, we will not talk about it in terms of slope, but that would mean the same thing. Because the slope is how much the y changes divided by how much the x changes. And that's what tangent is. The y value divided by the x value. How much you're changing in the y divided by how much you're changing in the x. Yes. guys, and this is, you've never heard this before, so this is something that you really need to make sure that you're paying attention to. Alright, we have these three trig functions. These three trig functions are the sine of theta, we've talked about the cosine of theta, we've talked about the tangent of theta. There are three more trig functions.
I heard you talk to them about it.
Yeah, probably have heard me say them before, but there are three more trig functions. And those other three trig functions are called cosecant, secant, and cotangent. So, let's write that down because you've never seen the spelling before either. Cosecant is spelled C-O-S-E-C-A-N-T. And I am writing cosecant right next to the sine for a reason. Do you see how the sine starts with an S?
Yes.
Cosecant starts with a C. And you'll see what I mean by that in just a minute. Just remember that. Sine starts with an S, cosecant starts with a C. By the way, the abbreviation for cosecant is CSC. CSC of theta. Cosine starts with a C. There's another trig function called the secant of theta, abbreviated SEC of theta. Notice that it starts with an S. Do you see why I just did that? Sine starts with S, cosecant starts with C, cosine starts with a C, secant starts with an S. And I like to think of sine and cosecant as kind of going hand in hand. Same with cosine and secant, they kind of go hand in hand. There's one more trig function. Now this rule, the CSS rule doesn't apply. The other trig function, the last of the six of them, is the cotangent of theta, and it is abbreviated as cotangent, C-O-T of theta. And I think that one's easy to remember just because it's tan of theta, cotangent of theta. Now, what are these things? Well, it just so happens that the cosecant, CSC of theta, is the reciprocal of sine. That's why I have them written right next to each other. So this is what I remember, is that cosecant, because it starts with a C, it is the reciprocal of the trig function that starts with an S. So cosecant is the same thing as 1 over the sine of theta. And then secant, SEC of theta, that is the reciprocal of, take a wild guess,
Cosine.
cosine. It starts with an S, so its reciprocal starts with a C, and then cotangent of theta is equal to 1 divided by what, you guys? 1 divided by tangent of theta. Now, this is your job tonight. Your job tonight is to make sure that the tangent row of your table is filled in. By the way, I am very impressed with how the bell rang and you remained in your seats.
I was tempted.
You don't even know. I was about to.
Thank you.